The important thing about mathematics is that it involves abstraction and symbolism. These are the ingredients of higher order mental processes, which is what we want our children to develop. Every topic we teach should aim to develop higher order mental processes, and mathematics, above all other subjects, makes this possible.
We've come to Scott's Primary School in Snowy Hornchurch, Essex, to see maths teacher Gary Clapperton teach a lesson on geometry to a Year 6 class. Scott's Primary is an open plan school of 210 pupils, 10% of whom come from an ethnic background.
My name's Gary Clapperton. I've been teaching for about 36 years, but here at Scott's I've been for about 10 years. I'd actually went straight from school to college, then into teaching, but I've done lots of other things in my spare time. Probably the most interesting was for about 6 years I did some comedy writing for people like Russ Abbott, Little and Large, Spitting Image, that sort of thing. Richard Dunn first came to Scott's about 3 years ago and explained his ideas to us to make maths make sense, and we've been using his ideas since then. I think Richard's basic idea is to make maths make sense. That's exactly what he does. Now we have ways of teaching children maths that make sense to them, therefore they find it much easier.
I've turned through that angle.
In today's lesson we're looking at explicit and implicit shapes, which are difficult to say in the first place, even more difficult to teach. And then the children will be going to drawing those shapes. Because they're Year 6, today's lesson will involve quite a lot of revision. But one thing I think they might have trouble with is ratio. I'm hoping that my explanation as we go through the lesson of how to draw the shapes using ratio will help them.
Gary's involved the children in taking photographs of buildings around them, and they'll be using these photos in the lesson today. He's also made use of these images on the interactive whiteboard.
What do we call the corners of shapes? Jack?
Vertices.
Good boy, vertices. But that's the plural. If we've got just one corner in maths of a shape, what do we call it? Stanislav?
Vertex.
Very good. So we've got the shape with 4 vertices, but I'm going to label these vertices. Remember, we must always label with capital letters. It doesn't matter where we start. I could start halfway through the alphabet. But in this case, I'm going to label the first one A, so it's A, B, C, D. So this shape, A, B, C, D, what can you tell me about it? Philip?
It's a rectangle.
Good, a rectangle. What I want you to do on your photo is to draw the polygon I've drawn on the board and label it as I have labelled it, but then find some other explicit polygons on the photo, draw them and label them. I'll give you a few moments to do that. Off you go.
By using the children's photographs, Gary's hoping to raise their awareness of the shapes around them and give the class a sense of ownership of the lesson. Today, Gary is supported by teaching assistant Kathy Briggs, who will be working one-to-one and in small groups within the class.
OK, Year 6, stop there, well done. Put everything down. We want to see what shapes you found on your photo. Who would like to come and show us on the whiteboard an explicit shape? Here, Michael, show us your shape. Well done, Michael, thank you. What can you tell us about the shape Michael found? It's an explicit shape because you can see it very clearly. What can you tell us about it, though? Adam?
It's a quadrilateral.
Correct, it's a quadrilateral. Anything else? Holly?
It has 4 right angles.
Are you sure? Look closely. How many right angles can you see?
None.
So it took no right angles, has it? Never mind. What else can you tell us about it? Sharp?
It has 2 pairs of parallel sides.
Yes, it has 2 pairs of parallel sides. Can we begin to give it a name? James?
It's a parallelogram.
Good, it's a parallelogram. Who else wants to come out and draw their shape on the whiteboard? Jack, come and draw yours. I've been using an interactive whiteboard for about 3 years now. Like most people at first, it was daunting, but I made the decision from the very beginning to take my blackboard away, so I was forced to use it from the start. And I think if you start just using it like a whiteboard or a blackboard, and then take it from there, learn things as you go along. But I would never, ever go back to a time when I could not use it. What can you tell me about Jack's shape? Matthew?
It's an isosceles triangle.
Very good. It's an isosceles triangle. Who thinks it's a right-angled isosceles triangle? Good, it isn't. Well done, well spotted. So, if I get my ruler, and I'm going to draw one side of the shape, doesn't really matter how long I make this side, a reasonable size, not too big, not too small.
Recapping with the class how to draw a regular mathematical shape leads Gary on to a neat way of demonstrating ratio.
This now must be the same length as this side, so I can draw it in. And I now have drawn my explicit shape. And it doesn't really matter what I do to this shape if I move it around. The angles are still right angles. The sides are still the same ratio. I can turn the shape and it's still the same. Same ratio of sides, same right angles. I can even spin it round. Even though I'm a bit dizzy, I can still see it's the same shape. I could even make it smaller. It's still got 4 right angles. It's still got this same ratio of sides, 1 to 2. If I make it bigger, it's still the same. Still got 4 right angles. I'm going to label it like I did before, A, B, C, D. Now you're going to have a go. So make sure you've got a piece of plain paper in front of you, a pencil and ruler. You've got to first decide how long that top edge is going to be. All done? Good. If I go back to the original photo, this house is out there somewhere. It's there in real life. And we call the actual house, or even a photo of it, the real life story. And on that house, it does have these explicit shapes, which we can see. They're real. So we call any of these shapes we can see the real story. However, once we start drawing these shapes like this and labelling them like this, it's no longer a window of a house. It's a rectangle, ABCD, or quadrilateral, ABCD. So this is called the math story. Let's go back to the picture and look at Jack's shape, which he drew. Roughly, what would you say that angle is there? Jacob?
100 degrees.
100 degrees. So you think it's more than 90 degrees?
Yes.
Who thinks it's less than 90 degrees? What do you think is the size of this angle then, Lauren?
45 degrees.
Who thinks 45 is too small? What do you think, Greg?
80 degrees.
Who agrees with Greg? It's about 80 degrees. So do I. Only roughly, about 80 degrees.
Gary's asked the class to draw triangles on some plain paper. Then to try and find some explicit shapes in their photographs, making sure they understand the explicit concept before moving on to find implicit shapes.
Who else would like to come out and show us a shape they found? Billy. I thought this one was difficult. Here you are. Shall I say shape? Good. Don't go away. Who agrees it's a right angle triangle? Who agrees it's an isosceles right angle triangle? Good, it isn't, is it? Well done. What is it then? Dean?
A right-angled scaling triangle.
Who thinks it's a right-angled scaling triangle? Good. We're going to go on to implicit shapes. And if I go back to the very, very first shape I drew. If I draw a line from corner to corner, I can now see that inside that rectangle, hiding, were two triangles, two implicit shapes. What you've got to do is see if you can find any of these implicit shapes, the ones which are hidden, they're hiding, difficult to find. Then have a go at drawing it on your plain paper.
That's an implicit shape. That's an explicit shape.
Yeah, it's that one. This one is it's another trapezium. No, it's that.
So Stanislav, show me this implicit shape you've drawn on here.
There.
And what is it?
A trapezium.
Would it be better, though, to maybe draw in the diagonals? Because this line here you could put almost anywhere. You could do this from infinity along there, couldn't you?
Yeah.
Have a go at that.
It's coming towards the end of the lesson and time for the plenary. So just how many of them will have understood the concepts of explicit and implicit shapes, ratio and angle?
Who did manage to find one implicit shape? Let's just check though. What is an explicit shape? Hannah?
Shape that stands out.
Yes, a shape that stands out. It's very clear, you cannot miss it. What is an implicit shape? James?
It's a shape that's hard to see or
It's-
doesn't stand out as much.
Yes, it's hard to see, it doesn't stand out so much. It's usually hidden amongst the other shapes. When you're drawing shapes from real life and making them into a maths story, what do you have to think about to draw them accurately?
The ratio of the sides.
Good, the ratio of the sides. What else have you got to look at? Matthew?
The angles.
Yes, good. You've got to estimate the angles. Well done, Year 6. We're at the end of the lesson and you've done really well on what's actually quite a difficult concept.
My favourite bit about the lesson was drawing on the pictures. An explicit shape is like showing out to you, but an implicit is harder to find.
Math story is talking about the shapes that are in the picture. The real life story is the actual picture.
On the whole, I was very pleased with how the lesson went. I was worried at the beginning about the ratio aspect, but I think they took that on board very, very well, much better than I thought they would. If I look back at the learning objective, which was to identify explicit and implicit shapes, I think on the whole, they did do that very well.